day, students. Mr. Sargent here with your Friday recap video. Now, as we know, every Friday we do a lab. Very good. Now, for today's lab, we're going to continue talking about energy. Now, one focus on energy that we're going to be really looking at today is gravitational energy. And our lab today, definitely going to be a fun one. But, ladies and gentlemen, I'm in the wrong gear. So, boom! All right, I got my lab coat. I got my brand new safety goggles because, ladies and gentlemen, safety first. And for today's lab, you're going to want to be safe. Now, before we get into today's lab, let's focus and review on our new unit, and that is energy. Now, the definition of energy is the ability to do work. You think about what energizes you, you think about what energizes the lights, you think about what energizes the camera right here, or the TV or computer you're watching this on right now. It's energy. Right now, energy is doing work. Now, the first energy source or energy that we're going to be talking about is gravitational energy. And just looking at the word, you can kind of tell what the focus is going to be, and that is gravity. Now, we know gravity is the force that keeps us on Earth. It pulls us in so we don't fly off into space. Now, we don't do that. Now, to create gravity, all something needs is mass and rotation. Now, mass is anything that takes up space. I take up space. I take up a lot of space sometimes, especially after a big meal. If I was spinning around, I would have gravity. But would I have enough gravity to, say, attract this book here? Probably not. Because on Earth, because the Earth is so massive, well, there's the word again, mass, that the power of gravity on Earth outweighs any energy that we can create through gravity. But I'm kind of glad it does because I don't want books flying at me all the time. Now, when you think about things that have the most gravity, we think about the sun. The sun is so huge or massive that it is able to pull in a number of planets and keep them in orbit. Now, on Wednesday, we took a look at attraction versus repelling. Now, attraction is sort of like a magnet. A magnet has a positive and a negative side, doesn't it? When you have a negative and a positive, they will attract. Now, if you look right here, you will see two magnets attracting. Pretty simple. We know how magnets work. But if you have two positives or two negatives, look what happens. They repel. Think about gravity that way as well. Gravity has a positive and a negative as well. Right now, we could be a positive while the gravitational energy on Earth is a negative. This is why we stay on Earth. But if you look at, say, I don't know, the sun and Earth, they both have gravitational pull. One may have a plus, the other may have a plus. They will repel. And I'm kind of glad that they do because, well, it'd be kind of hot if we got any closer to the sun. So what we're going to do today is try to think of a way to defeat gravity. Now, to help me, I have one of my favorite books. It's called The Book of Totally Irresponsible Science. Well, ladies and gentlemen, don't worry. It's very responsible science. It's just a very clever title, but looking at it makes me feel almost like a mad scientist. I know what just happened. No, we're not, he's not coming back. Ladies and gentlemen, what we're gonna do is we're gonna take a look at an experiment from this book, and we're gonna see if we can see the effects of gravity, possibly defeat gravity, and have some fun doing it. So, ladies and gentlemen, let's go ahead and get started. Before we continue our lab, I want to dedicate this video to all of my students that are at home right now watching this, unable to be at school. Ladies and gentlemen, miss you. Denzel, Nova, Jaden, cannot wait to see you all real soon. All right, so we have our materials here. We have our totally irresponsible book of science right here. And I got my trophy right here. We're gonna use the trophy in a little bit. So as we know, every lab starts with a question. And our question today is, can we create something that defeats gravity? We have a saying in second grade, gravity always wins. But can we create something that kind of defies gravity? Well, we're gonna try today, ladies and gentlemen. And my hypothesis is, I think we can. I've never done this before. I know some of you may have done this before. I haven't. So I'm not too sure about my hypothesis. Now, our research has been all week, we've been studying about energy and gravity and gravitational energy. So taking what we know and knowing about rotation, knowing about mass, can we defeat gravity? Well, I kind of hope we do. So step one, ladies and gentlemen, is going to be gathering our materials. Now for this experiment, you're gonna need some string. Yarn is preferable, but I have some string here handy. You're gonna need a piece of cardboard. I have a hole punch, which is really gonna help. Do we need it? Probably, but can you do without it? Maybe. I got some tape if I ever need it, and a pair of scissors if I ever need it. And then I have my supplies. I have a trophy, I have a wiffle ball, I have a cup. Now, I'm using paper cups. We don't want to use glass or anything that's going to break because, as we know, gravity always wins, and if the glass falls, well, you know. So what we're going to do is we're going to create something that hopefully defies gravity. So the first thing you need to do, step one, other than gathering your materials, is get your piece of cardboard and punch 4 holes in it. Usually you want to do this at the corners, just like that. See how I did the 4 holes? All right. So our next step is going to be to take our string and get a cut. Now you're gonna want your string long enough. You're gonna see why in a second. My string is roughly about 5 feet long. All right. Now we can always cut the string if it's too long, but we kind of want it to be long. So here's what we do. We put it through the hole here, and then we bring it up the other hole over here. So just like that. Then we take the other side and we do the same thing to the other hole, where we go up okay, where we take this and go through, pull it tight, and then pull it up. All right. So if you look at the bottom, it looks like that, and the top looks like this. But we don't necessarily want everything on one side. So what we do is we're going to take this side over here and pull it up. You see what I mean about having the long string? It's really gonna help you. All right, so here's what we do. We take our string and we tie all 3 pieces together. Now, this is where the tape may come in handy. If you're not good at tying, it's okay not to be good at tying, but if you're not good at tying, this is where you would wrap this in tape. But I think for this experiment, I am just going to tie up the 3 pieces like that. And just make a knot, okay? So if you did this right, which I kind of did, you will have 4 strings going down, all pulling our piece of cardboard. Kind of looks like a swing, doesn't it? Well, that's kind of the premise of this experiment, is to sort of create a swing. So if we put something on it, it should stay right on the swing. Now, you think about how this is defeating gravity. Well, the cup's not falling because we're using enough energy back here to sort of hold it up, aren't we? All right? But this is a fairly easy part. You know, in Mr. Sargent's labs, we have to kick it up a notch. So, our next thing that we're going to do is, I'm going to move this table out of the way, and I want to see if I can go all the way around with the cup still sitting on our swing. Well, I'm going to let you guys and ladies make the hypothesis whether or not it's going to work. But let's go ahead and test it out. It worked! But why did it work? Why didn't the cup fly off until the very end? Well, if you said gravity, you're kind of on the right path. Now, gravity wants to pull this down to the ground, doesn't it? But we are creating enough force and enough energy to sort of defeat gravity. So even when it's upside down, it's still going to stay because, well, we have rotation, don't we? But let's kick it up a notch a little bit. Let's see if mass has something to do with it. This cup is really light. Do you think something heavier will fall quicker? Well, we know that weight is determined and based on the forces of gravity. So let's see if weight has anything to do with it. So what I'm going to do is I'm going to leave the cup, but I'm also going to add a wiffle ball. And let's see if it works. Test 2. This time, I'm going to go a little bit faster. It worked, ladies and gentlemen. Adding the extra speed definitely helped out. Well, but why? Well, ladies and gentlemen, because the end of the energy transfer, we had more mass. Therefore, we had more gravitational energy that we had to, well, kind of repel and go against. So, by adding the speed, what we're doing is we're adding the energy from our hands and our arms and creating more energy in order for it to spin. And if you notice, the ball's still there, isn't it? So by adding our own energy to it, we're able to sort of not beat gravity, because gravity's always going to win, but we can defy it for a little bit. See, as you remember, energy cannot be created, energy cannot be destroyed, it can only be transferred. And if we're doing something that needs to sort of defy gravity, whether it's jumping or throwing a ball, the longer and more energy that we put into it, the further we can throw the ball, the further we can jump, the higher we can jump. But we have to add and transfer that energy. But ultimately, gravity is always going to win. So if we go through the rest of our experiment here, we already did the question, we did the hypothesis, we did the research, we did the steps. Let's talk about the results. The results are, it worked when we added enough energy to it. And our conclusion, did we achieve something that defied gravity? Yes and no. Yes, as long as we are, that's right, as long as we're spinning it, we're defeating it. But the minute we stop, what happens? You're right, it falls. Because ladies and gentlemen, gravity always wins. As long as the Earth's rotating, as long as the Earth has mass, ladies and gentlemen, we have to follow the laws of gravity. So ladies and gentlemen, I hope you had some fun today. If you tried this, definitely be careful, because you never know, if we don't add enough energy, things may, well, go flying across the room. And ladies and gentlemen, we don't want that. So safety first. And ladies and gentlemen, I hope you all have a great weekend, and I cannot wait to see all of you next week.